Br negative, thank you. So that's the conjugate base. What is the conjugate acid of OH minus? H2O. You gain, after gaining another proton there, you have OH minus to begin with, you put another hydrogen in there, hydrogen ion bears positive charge, negative charge, neutralizes, you end up with H2O. So what's the conjugate base for phosphate ion? One of those 16 polyatomic ions that I asked you to memorize in chapter 2. What's the conjugate acid for HeO4 3 minus? I will wait to 10 o'clock until you give me an answer.
HeO4 2 minus charge.
Thank you. So you add a hydrogen ion to it, positive charge, a positive charge, 3 negative charge, you end up with 2 negative charge. So HeO4 2 minus. And this is something that we want you to be able to do. What's the conjugate base for HClO4? Perchloric acid. ClO4 minus. Now you get it. So what's the conjugate acid for HSO4 minus? 2 minus. Well, conjugate acid actually has obtaining hydrogen there, so H2SO4. You're adding a hydrogen to it. Now the same species there, we can ask you, what's the conjugate base for that? Well, that's when you have SO4 2 minus. So you need to know how we define acid and how we define base, and how do we define conjugate acid and conjugate base. Conjugate base is the result after the acid gives out the hydrogen ion. Conjugate acid is the result of the base acquiring the hydrogen ion there. And then some of the species there, you see, they can act either as an acid or a base. So water is not the only substance that's amphoteric. And HSO4 in this case, HSO4 minus can act either as an acid or a base. And they can take in a hydrogen ion, acting as a base. Again, they can also donate whatever they have there, one hydrogen attached to it, and that's an acid there. Okay, so definition, this is what we're trying to focus on. And again, when you get into Chem 102, your instructor is not going to spend any time talking about conjugate acid, conjugate base. They will assume you know what they are. So they are going to use the term when they start talking about the acid base there. So what's the conjugate base of the NH3? What's the conjugate acid of NH3? You need to know the definition. Okay, so this is what we want to introduce in Chem 101 before you get into Chem 102. That's our first learning objective. We give you a lot of definitions there, and you got to know the definition. Second, well, next logical question there, second learning objective there is, how do you measure, how do you determine what we call the acidity or basicity of a solution when you have an acid base, when you deal with acid base? We use what we call a scale we call a pH. Well, the P scale, by definition, is the negative log of whatever quantity. So pH is the negative log of hydronium ion concentration, hydrogen ion concentration. pOH, by the same token, will be the concentration, negative log of the concentration of hydroxide. So we need you to be able to do calculation, figure out the pH and pOH if the concentration of the solution is given, or be able to figure out the concentration if the pH is given. Okay, so first of all, how do we define acid base? And we give you the definition there. But something interesting about water, aqueous solution there, is that water can actually act either as an acid or a base. Now, what happens if you put two water molecules together? Well, there is what we call an autoionization of water. Not on a large scale, on very small scale there. This is what's happening there when you have two water molecules close to one another. One water molecule will be able to take the hydrogen ion from the other, forming a hydronium ion, and then what's left for the other water molecule would be the OH there. So you end up with an acid and a base with neutral water there. Now, thank goodness this is not happening on a very high level there, or rather it's actually happening at a very low level. And the water is a very weak electrolyte. Now we say pure water does not conduct electricity. simply because we don't have a whole lot of charged ions, H3O plus or OH minus. Okay. And in this case, how low is the autoionization and the level of autoionization? About 2 molecules of water out of about 1 billion water molecules will go through this process. So you don't really have a very high concentration of the hydronium ion, hydroxide ion concentration. However, this is very important. When you have water, water can dissociate, can go through the autoionization. At a certain temperature, the concentration of hydronium ion, H3O plus, and hydroxide ion, OH minus, is fixed. Okay. The product of those two concentrations remains at a constant, remains as a constant when the temperature is fixed. So for water or any aqueous solution, the concentration product between hydronium ion and hydroxide ion is a constant. At 25 degrees, that constant equals to 1.00 times 10 to the negative 14. Now, this constant is called autoionization constant of water. Very important number to remember, 1.00 times 10 to the negative 14. Okay. Now, in any aqueous solution, if you know the concentration of this, you can figure out the concentration of this, or the other way around, because the product of these two equals to a constant. This is very much similar to that wavelength and frequency relationship to the velocity of light. Lambda times nu equals to the speed of light. So the concentration multiplied by one another equals to a constant. So if you know the concentration of one species, you know the concentration of the other. 1.00 times 10 to the negative 14 divided by whatever whatever it is given, and you find out the concentration of the other species there. Okay. So in this case, hydrogen ion concentration or hydronium ion concentration and hydroxide ion concentration are inversely proportional to one another. One is lower, the other is higher. The product ends up with a constant there. Okay. Now, solutions are classified based on the concentration. Water solutions are classified based on the concentration of hydronium ion and hydroxide ion. If you have a higher concentration of H3O plus, we say the solution is acidic. If you have a higher concentration of OH minus, we say the solution is basic. If you have equal concentration of both, no, the solution is neutral. Depending on the relative amount of these two species there, we have these 3 different terms to describe the property of the water solution: acidic, basic, or neutral. Okay? So in this case, how is acidity, basicity measured? Well, acidity or basicity of an aqueous solution is measured by what we call pH value. pH value, or the P lot there, pH or POH. pH by definition, that's a definition there, that's a D word. Okay. pH by definition is the negative log of the molar concentration of H3O plus. POH, negative log of hydroxide ion concentration. So if we give you the concentration of either of these species there, all you need to do is to take the negative log of that concentration. Now we'll give you the pH or POH. And Kw, in this case, equals to the concentration product of these two species, and that equals to a constant there. Now if you take the negative log on both sides of the equation, you get negative log of this times this.